If an NMOS FET has a threshold voltage of the following with VSB, whereas what is the threshold voltage in volts with the following numbers? So we're going to explain this problem, we're going to walk through it, and each step. The problem might be different for you because you have different numbers, but we'll go through and show what you need to do if the numbers are different and how to solve this. The first thing that we're going to do is use the notes that are in the description below the like button. There's a page with the following notes on it right here. With these notes, we are going to solve for it. This is for the effects on both large signals and small signals, what we have right here. Vt is equal to all of this, and we essentially want to use this entire part to solve our problem. Now, this Vt naught right here is actually given to us. It's the threshold voltage of 0.52 volts. And we can see that in our final solution right here. That's the first thing that's put in. Now we're going to solve for everything else. So we first have this part right here. And after we look at this, we can see in the notes that this is going to be equal to all of this right here. So let's solve for that. The first thing that I'm going to look at is the COX. We can find this in the notes as well. This is a given equation that we can use. So using this is essentially all given except for this TOX, which is 37A with the little circle on top. Now we can either do this in meters or we can do it in centimeters. You just need to make sure that you're using the correct one. So currently, if it's 10 to the negative 14 for the E naught, it's going to be F over centimeters, like this. For F over meters, it's 10 to the negative 12. Now, I actually did this a little bit incorrectly on the bottom part right here, so we can correct it right now. This should be it should be 10 raised to the negative 12 for centimeters, and this is going to equal to the F over centimeters squared. So this is our answer right here. This 37 is getting plugged in from here, so you substitute it for whatever yours is. And this is going to be our equation. We can write it like this as well. Now, we are going to use this and plug it into here, but first we need to solve for this top part. We're going to take a quick break from that and solve for this right here. Now, this part is going to be equal to the following right here. You can put the 2 in or you can leave the 2 out. It doesn't make a huge difference because of the types of numbers we're dealing with, but we'll leave the 2 out for here and just solve it like this. So this is equal to the thermal voltage, so KTQ. There are constant numbers here. The only thing not constant is our specific temperature, but that's at 27 degrees Celsius, which is pretty common. You can go onto a website that I'll have in the description below the like button for a thermal voltage calculator, and it'll calculate the K times T divided by Q. And you're going to get something that looks like this. Then you have your Ln. Your Na is given to you in the problem. Your Ni is a constant of 1.45 times 10 to the 10 centimeters, and then raised to the negative 3. So I believe it should be negative 3. We're going to get a 0.451 from here. This should be like centimeters to the 6, I believe. Now, with all that information, we can go ahead and do this last part. This last part right here is the top part, arguably the longest part. So starting this off, we have our 2 right here. Our Q is a constant, it's for electrons. That's also in the notes. We have our Na, which is given to us in the problem right here. We have our Ks. Ks is also constant, and it's in the notes as well. We have our E naught, which is just going to be this right here. And then I wrote down some of the units for this as well. So with that in mind, we can finish this out. We are going to take our COX. We are going to plug it into here. And then from all of this, we will get this. Now that's a combination of the top and the bottom. So everything combined is going to give us this number. Now let's go back to our original equation right here. We are going to plug what we had right here for just this part into here. So we have this, and then we have the square root of let's combine everything together now. We know our VSB is given to us as 0.89 volts. So 0.89 volts. And then this next part right here, 0.451 being multiplied by this 2. You can see it's the same thing here and here. It's just going to be what we solve here. And remember that there's supposed to be in absolute values. And we're going to plug all of this into a calculator and get approximately 0.52. So that's how we would look at this problem and solve for it.